Right, this is a practice video on transformations, and what we've got to do is generate some random problems. Okay, so we've got problem A, problem B, problem C, and problem D. So we're going to roll 2 dice to fill in the square boxes, and then roll a sine, cos, tan die like this to define the function. So then we can go ahead and sketch the graph. Okay. So let's start by rolling our dice. That's 4. Okay, so let's put 4 in here. Next roll, I get 3. Okay, let's see, 7. And 2. Oh, 2 again. And the 11. Let's roll again. 12. And one more time. No, 12 again. Shall I re-roll that? No, let's just accept that. Okay, so we've got 12 and 12. Okay, now I've got my little tan, sine, cosine dice with some stickers on each side now. And so that's cosine. Okay. Next one's going to be what? Tan. Okay, so tangent. And I'm hoping for something new here. Oh well, no, I've got cosine again. And finally, well, I don't want cosine again. Let's have another roll. Sine. Yeah, okay, very good. There we go. So there's my randomly generated functions. Let's work out the problem. Okay, so problem A, let's draw it here, is what? It's y equals 4 cosine of 3x. Now, I'm going to start by identifying my period. So what would the period of this be? Well, normally it would be 360 degrees for all the functions apart from tangent and cotangent. So 360 is my starting point, and I'm going to divide this time by 3 because this 3 here means it's going 3 times faster around the unit circle, if you like. So divide by 3 and I get my period. Well, 36 divided by 3 is going to be 12, so it's 120. Okay, so there's my period. That means that when I draw my graph, in fact, let's make a quick note here. I'm going to draw it from minus 60. Okay, so this is on the x-axis to 60. Let's just jot that in small letters in brackets. Okay. Next, let's think about the amplitude. Let's just call it amp, maybe. By amplitude is given by this multiplier here, which is 4. So if my amplitude is 4, I'm going to go between minus 4, this is my y-axis, and 4. Okay. So now all I've got to do is sketch the graph. So let's draw my axes like this. I'm going to put my 0 here. I've got, okay, on my x-axis, minus 60 to plus positive 60, let's say. And I'm going to put quarter values in here. So normally, this would be obviously 360, so you'd have 0, 180 and 90, and I'm going to think of that, and minus 90 or minus 270 and minus 180. So, sorry, minus 180 or 360 in other words. So what I'm going to do is work with those normal values because I know what the cosine graph should look like, but just keep it within this 60 to minus 60. So in a sense, I'm going to ignore the 60 to minus 60 values. Okay, now that I've marked them on. Now I'm going to also have 4 here And again, I would usually think about this as just 1, because with the cosine we're talking about the unit circle, and so the value of cosine not normally going above 1. And down below, -4. So that's sort of thought about what I'm doing, and it's also just put in the values that I know I'm going to need. Now all I've got to do is draw the graph. Let's think. Now if it's cosine, actually what I need to do is just move this 4 up. So I'm going to move this 4 slightly out of the way, because I know that at this point here, which would normally be 1, I'm going to get a y value of 4, but it would normally be a y value of 1, but it's going to intersect the y-axis at this point here. So let's just draw that in like that. Now, where would it actually intercept the x-axis? Well, where it would normally be cosine of 90. Okay, so the cosine of 90 is 0, so it would normally intercept here. So I'll draw that in like that. I'm also going to think about what would normally be my 45-degree values. Well, that would be √2/2. So if this would normally be 1, that would be 0.7, about there. Okay, so putting these dots in just helps me to think about how to draw, where exactly I should draw it, the sort of shape of it, which is slightly bulging out then. And if I draw this one here, now what's going to happen here? We're going to go to minus 0.7, minus √2/2, which is going to be about there. And then at 60 degrees, but what would normally be 180 degrees, the cosine is going to be -1, what would usually be -1, but now has become -4. Okay, so if you keep in mind the shape that you want to get, not worry too much about these distorted values here, then everything's going to work out okay. So let's put our -60 there, tail it off here, and we want to just put a little dot there. There we go. Just put a line through, and now I think we can just join everything up. Okay, there we go. It may not be a work of art, but it's looking like a cosine graph. Okay, like that, and then the final bit of the jigsaw. There we are, and there we've completed it, and that's a full period. If we imagine translating this to the right, then would it start again? So we go up and down, and then it would start again just like that, so it would go up and down again, and so on. So good, that looks right, and time for us to move on to our next one. Right, so let's get my pen back. Okay, so now we have, let's write it down here, b, y equals, well, what have we got? 7 tan of 2x. Okay, so if you want to pause the video here and give this a go yourself, great. Otherwise, let's just follow through this worked solution. All right, so the period is going to be, well, normally with most functions it's 360, but we have to remember that with the tangent and cotangent functions it's 180. So with that in mind, we write 180 divided by 2, giving us a period of 90 degrees. Now, 90 degrees would usually split into -45 to 45, but what I like to do with the tangent function is show 2 periods. So I'm going to make it from -90 to 90, like that. Okay, so that, oops, let's just write that properly. But let's just make that 90 look a bit nicer. Okay, so I missed out my, well, let's just write 90, okay, and that's a bit better. So minus 90 to, there we go, less than or equal to 90. So that's the range for the x-axis. Now for the amplitude, well, the amplitude is going to equal 7. Okay, and that means that the range for the y-axis is going to go from minus 7 to 7. Okay, now let's sketch the graph. Alright, so let's start with our minus 90 here and positive 90 here. Put our 0 in, and our y-axis, I should have written that actually, so there's x, there's y, there's x and y. Okay, so now we've got to put in 7, put that there, and minus 7. Okay, now to sketch a tangent or cotangent function, or one of the other ones that has asymptotes, what we're going to do is, let's just see, if we think of the tangent of 90, then the tangent of 90 is going to be undefined. So we're going to have our asymptotes then here, in other words, at this point. No, we're not, sorry. My mistake. Normally it would be at 90, but of course we've got a distorted function here of 2. So, my mistake. We've got to think then of how this would normally go. So 90 would normally be here. So let's draw our asymptotes down at where 90 would normally be, because our graph, of course, is going to be compressed. Okay. There we go. So that's got our asymptotes in. Now all we need to do is draw the function. Well, we know, or we should know, that the tangent of 45 degrees is 1. It's a nice, easy one to remember. So 45 degrees would normally be here, and so 1 is going to be normally there. But in this case, because we've got a range of 7, and we're trying to reflect that range, in fact, what we should say is that we don't really have an amplitude, we simply have a range, because there's no peaks and trough with a tangent, so I'm just going to put range here instead of amplitude. So where this would normally be 1, this is going to be 3.5. If I just mark that in as 3.5, then 1 is going to be, well, let's say it's about there. Okay, 1, 2, maybe a little higher. Let's just get it as close as we can. We want to get the shape right. So less than a third, so about there. Okay. So we've got our 0. The tan of 0 is 0, so our 0 point would be here at the origin. We're going to go to here. I'm going to think of also 60 degrees. So this would normally be 90. Around here, 2/3 of the way along, would normally be 60. We should know that 60 is root 3. So root 3 is about 1.7, 1.73, something like that. So that's half of 3.5. So quite conveniently, you can mark that here. Okay, just delete that other mark. Okay. So now we know also that it's going to disappear off our graph, let's say about here. We can join then this up like this, and there's the first part of our tangent function. Now it's then going to reappear about here. Again, if we think of, well, if we think of this 60 degree point here, which isn't 60 degrees, it's a fake 60 degrees, then that's going to be at about half. Our fake 45 degrees is going to be at about 1, which we said was about like that. So that gives us enough to draw it up to the 0 point there at 90 degrees. And so you can have something like that. Now that would be fine if you wanted to sketch it like that. I just like to see how it develops on the other side as well. So at 45 degrees we've got 1, then we have this point here at half, so that gives us our guidelines for here, and then heading towards that asymptote and then tailing off. And here again we're going to have it reappear up here somewhere down to, where is it, about there, and here. So let's join that up like that. Okay, so 2 periods of the tangent. I didn't draw that very well. Let's just make sure that goes up and doesn't curl back. Okay, but I think that's good enough and shows us y equals 7 tan 2x. Right, now then for y equals 2 cos 11x. So let's draw that here. Y equals 2 cos 11x. Okay, that's an interesting figure. It's going to give us a few difficulties, but let's see how we go. So our period, well, period for a cosine is going to be 360 divided by 11. Now, I can't do that easily off the top of my head. Let's use a calculator, I think, on this one. That's obviously, it's not going to simplify, so 360 divided by 11, there's no way of simplifying that. So our calculator says 32.72 recurring. So that's an interesting figure. We'll use that as our range. I'm not going to do the x values here, I haven't really got enough room, but you can see how this is going to work. I'm going to go from, so it's going to be half of that, isn't it? So it's going to be, well, let's draw it in here now. So 2 into 32 is going to be, I'll draw it like this. 2 into 32 is going to be 16. Okay, so minus 16, and 30.36 recurring then is going to be half of 0.72. Like that. Okay, so let's just check that. 16.36, well, 32.72 recurring, in other words 360 divided by 11 divided by 2 is obviously going to be 180 divided by 11, so yeah, 16.36 recurring. So just worth checking these things, make sure we're absolutely sure. Now that's going to be my negative then, and it's going to be less than or equal to, don't really like doing it like this, but it will do, 16.36 recurring. There we go. So that's put our x values in. I think it was worth doing because it did take a little bit of thinking about. All right, our amplitude. So our amplitude is going to be what? Let's have a look. 2. So this is a bit easier. Minus 2 to plus 2. Like that. Okay, let's sketch our graph. So if we've got a cosine graph, all we've got to do is put our values in just like this. So we're going to have, I'm doing the y-axis first because I want to just think about how I'm going to write the x-axis, but it's going to be, actually let's just move that up a little bit. So it's going to be plus 2 to minus 2 on the y-axis. Let's put our 0 in, let's put our x in, our y in there. Okay, now how do I write this? Oh yeah, okay, so if I put that there, and if I think about my cosine, I'm going to have plenty of room, so I'll write minus 16.36 recurring. There we go. It's a little bit of an unusual way to label an x-axis, but it's fine, it's going to work. Now, Let's erase this x here to give ourselves plenty of room. Put our marker in. 16.36 recurring, and put our x above here. That should work out quite nicely. Our quarter values are going to be here, whatever that is. But the way we're going to think about these are, well, it's between 180 and minus 180 and 180 normally, so these would be our 90-degree values. Okay, our fake 90-degree values, you might want to say. So we start with our 0 at 0. We know that cosine is also 0. So in that case, 2 times 0 is also 0. So there we go. We're going to have our turning point there. Sorry, not 0. What am I talking about? 1. Normally 2 times 1 is 2. So I do apologise. 2 times 1 is 2, and so we're turning at 2. Okay. And our 0 point, in fact, is going to be at our 90. So we're going to think of what we're doing here. We're going to have our root 2 point at the 45 degree, root 2 over 2. That's going to be at 0.7. That's going to be there and there. And you can just look over to your cosine here and see that we're making exactly the same pattern. So we're going to go there. And finally, we're down to what would normally be minus 1. So there's our turning point, our second turning point. And we're going to have a turning point here as well. Join them together. Put our lines in first. Okay. And we will have completed. There we go. Completed our second cosine graph. This one looks a little bit too straight. I want to just curve it a little. Let's just erase this. It just needs a little bit more curving. I think I didn't quite put my dot in the right place. Let's put it there. So curve it round. That's a bit better. And bring it down. There. Okay. So that's completed problem C. I don't know why I wrote B. Problem C. So lastly, I've got my very stretched 12 sine 12x. So let's write that down. Okay. So y equals 12 sine of 12x. Okay, so my period is going to be, well, with the sine function, 360 degrees, but it's divided by 12. Well, 360 divided by 12 is like 36 divided by 12 is over 3 times 10 is 30. Okay, so that's a slightly easier value than we had before with our 32.72 recurring degrees. And so my x is going to go from minus 15 to positive 15, like that. Okay. My amplitude then. Well, the amplitude is 12. Therefore, I have to remember to go from minus 12 to positive 12. Like that. Now I sketch my graph. And let's start this time by putting on, now I know I'm going to be able to fit my y in perfectly okay. My x with a sine graph, well, let's put the x here again, see if that works. Should be okay. I'm going to put my beginning and end of my period, because I'm just going with one period here. So it's going to be from minus 15 to plus 15, and my range is from 12 up here. I have actually run out of room, let's put it there, to minus 12 down here. Okay, now we're ready to sketch our sine curve. Well, here's our quarter values, there and there. So we need to think of what sine of 0 is to start with. For sine of 0 is 0, so we're going to start at the origin here at 0. Then at 90 degrees, or what would normally be 90 degrees, we're going to, so the sine of 90 degrees is going to be normally 1, in this case 12, so it'll be up here. Let's just make it clear that that's a turning point. And then it would come back down to what would normally be the sine of 180 degrees, which again is 0. Takes us back to 0 at this point here. So we've got this kind of shape going on here. We can think of our 45 degrees, so the sine of 45 degrees is going to give us root 2 over 2, which is about 0.7, it's about there, and about there. And, well, let's draw this one up then, and see what that looks like. Is this beginning to look like a sine graph? Yeah, that's quite nice. Oh, I think my drawing there has got a bit awry again. I do want a little bit of a bulge. So let's just have another go at that. So 0.7 about there. Let's bring it down a bit quicker, like that. There we go. That's more like it. Okay, and here I'm going to get my turning point at what is now minus 12, but would be minus 1, with the unit circle. And my minus 0.7 value would be there. So I can join that up now like that. My minus 0.7 value, whoops, there. And so, nice continuous line. I think that's good enough. So that completes this practice.